Nadia Ayala-Lopez is a third-year PhD student in the Department of Pharmacology and Toxicology at Michigan State in the lab of Dr. Stephanie Watts. She came to MSU after serving as a medical laboratory scientist in hematology at the University of Washington Harborview Hospital in Seattle. Her undergraduate degree is in clinical laboratory science from the University of Nevada, Las Vegas, where she conducted research in the field of immunotoxicology.
Thank you, Dr. Shu, for the introduction. Good morning. So today I'm going to tell you a story about norepinephrine transport in perivascular adipose tissue. So perivascular adipose tissue, or PVAT, is fat tissue that surrounds blood vessels. Most of your blood vessels in your body have them, except for the blood vessels in your brain. And norepinephrine is a molecule that constricts blood vessels, so it makes them smaller and can increase blood pressure. So I'm going to talk to you about what the relationship is between the two. And much of that relationship has to do with blood pressure. So I've been keeping track of my blood pressure lately, and when I was sitting, my blood pressure was 90/69. After running up 4 flights of stairs, I'm sad to say that I'm quite unfit, so it went really high to 153/128. Standing and talking, just like I am now, it decreased to about 98/74. So you don't have to worry too much about what the numbers mean, but just recognize that your body has this system of regulating your blood pressure when it needs to drive blood to the areas that need it. For example, when you're running and your muscles need oxygen. So what happens when this system doesn't work properly and your blood pressure stays high? Well, that's a condition that we call having high blood pressure. Another word for that is hypertension, and that's a blood pressure that's greater than 120/80. We are concerned with it because it is very prevalent in America. 1 in 3 Americans have it, and it is responsible for around 1,000 deaths a day. The reason for this high death toll is that when you have high blood pressure, you're 4 times more likely to die from stroke and 3 times more likely to die from heart disease. So in order to address this health problem, we have to start thinking about blood pressure. Well, what determines blood pressure? One is what the heart does, so how fast it beats, how much blood it pumps, and the other side are what the veins and arteries are doing, so the pressure inside of the blood vessels. That's where PVAT comes in. The fat around blood vessels actually can change the behavior and how they contract, and this can influence blood pressure. So to study how this fat tissue does this, we first took apart PVAT, and this is an image of nerves, precursor cells, fat cells, immune cells that are all in this complex tissue. But when we looked at just the isolated fat cells and measured norepinephrine, that molecule that constricts blood vessels, norepinephrine was present in the tissue and largely in the fat cells themselves. So how is this norepinephrine getting into the fat cells, and what is it doing there? So we hypothesized that fat cells have transporters on the surface that can actually take in norepinephrine. So could the fat in itself be removing norepinephrine so that the blood vessel then constricts less? That would be a good thing. I can't see norepinephrine, so I couldn't see this happening, but I have something that's close to norepinephrine that fluoresces, and that's this compound ASB+. So ASB+ is similar to norepinephrine in that it can go into transporters that transport norepinephrine, and I can see it under a microscope, and our fat cells lit up with this compound, saying that it did get into the cells. So then I looked for a specific transporter that can transport norepinephrine, and that's OCT3, and I found a positive signal. These are fat cells there that have been incubated with an antibody or probe for the molecule, and when it's there, it will cause a darker color. And the negative control, which didn't have that probe in it, didn't show reactivity, validating that the assay worked. So it's positive for this transport that can transport norepinephrine. So what we think is that PVAT, this fat, may act as a sink for norepinephrine. The fat then takes up norepinephrine, and less norepinephrine around means that the blood vessels contract less, which is a good thing if we're trying to lower blood pressure. But then what happens in disease? What happens in obesity and in hypertension or high blood pressure when this system breaks down? And those are our next questions that we want to start looking at. And the ultimate goal is to use the knowledge that we gain to understand this mechanism to find a target to lower blood pressure in people that have high blood pressure. And these are my acknowledgments. I'm going to leave them up there as we collaborate with many different people to make this research happen. But I want to specifically thank my research advisor, Dr. Stephanie Watts, and I will be happy to take questions.
Questions or comments? for the North Star.
Where do you get the sample of the fat that's on the blood vessels to
Yes.
examine it?
So we do get, we use tissue from rats, so from male rats. So they are a great model for blood pressure changes. So that is our preferred model.
Instead of calling it, what's the term, Norepinephrine?
Norepinephrine.
Why don't we just call it fatty tissue?
You mean PVAD?
PVAD.
So PVAD is perivascular adipose tissue, and so it's right against blood vessels, and it's very different from fats in other depots. So your fat that's underneath your skin is very different from the fat that's right around blood vessels, and that's sort of the mystery. So why is it so different? Is it because it has a function in itself that influences blood pressure and blood vessels? So that is a huge field of interest. A good question.
Other questions? So, thank you very much.
Thank you.
Thank you.